In this lecture, I'm going to be talking about another approach for event extraction, and we are using a generation-based method. The model is called degree. So I'm going to be focusing on this paper in 2022. Event extraction requires high-quality expert human annotations, which are usually expensive. Therefore, learning a data-efficient event extraction model that can be trained with only a few labeled examples has become a crucial challenge. In this paper, we focus on low-resource end-to-end event extraction and propose degree, a data-efficient model that formulates event extraction as a conditional generation problem. So it's an event extraction method that is a conditional generation problem. Given a passage and a manually designed prompt, degree learns to summarize the events mentioned in the passage into a natural sentence that follows a predefined pattern. The final event prediction are then extracted from the generated sentence with a deterministic algorithm. Degree has three advantages to learn well with less training data. First, our design prompts provide semantic guidance for degree to leverage label semantics and thus better capture the event arguments. Moreover, degree is capable of using additional weakly supervised information such as the description of events encoded in the prompt. It's like zero-shot learning that we also give the description. And finally, degree learns triggers and arguments jointly in an end-to-end manner, which encourages the model to better utilize the shared knowledge and dependencies among them. These are the two examples of events. For example, one event is justice execute and the other event is justice appeal. So you see that you have the trigger, for example, execution, and you have the arguments and the roles. But what is event extraction? It usually divides into two subtasks. First, you identify the event triggers and then their types, and then event argument extraction, which extracts the argument and the roles. For example, is it theme, is it cause, is it site, or in any domain we have a different kind of roles. So it triggers, for example, a verb, and then their types. It could be a protein, it could be a gene, and then their roles, how they are connected, how different mentions are connected to the triggers. Of course, comes from trigger. And we focus on low-resource event extraction, where only a small amount of training examples are available. In few-shot learning, we do few-shot learning because we have low resource. And we propose degree, a generation-based model, and these generative models, there's a paper says LLM models are few-shot learning models, so there is a very close link between them. You're implicitly doing few-shot learning, although you don't know it, but you're doing it. And it's not as explicit as methods like ProtonNet that do few-shot learning, but in the large language models, these generative models, you do it implicitly. But if you think about it, you see that even very small amount of examples are enough. So the event triggers and arguments can be extracted from generated sentence by using a deterministic algorithm. So we have an encoder and decoder like any other generative model, but your prompt is very interesting. For example, you have some templates that say some attacker attacks some facility, and then you output and you replace, for example, some attacker is this, and some facility attacks some facility by some way is bomb here because it's an instrument. You see different arguments. So it enjoys the following advantages to learn well with less training data. First, the framework provides label semantics via the design template in the prompt. So as in this example in figure 2, somewhere in the prompt guides the model to predict the words being similar to location. So somewhere is just location. And the similar things for other. But there are 3 contributions in this paper. First, it's a generation-based event extraction that learns well with just less data, better incorporating label semantics and shared knowledge between subtasks which we are interested. The second one, experiments on this ACE 25, which is very common for event extraction, demonstrate strong performance in low resource setting. And finally, we present ablation studies in both the low resource and high resource to better understand the strengths and weaknesses of our model. So it has a template. The first part is called ED template, which is event detection, which is triggered as event trigger is some trigger, where trigger is a special token serving as a placeholder. So attack event is some attacker attacks some facility. So each underlying string with some serves as a placeholder corresponding to an argument role. And these are 3 examples of the templates that you can use. For example, for event type life divorce, you can use this template, somebody divorcing somewhere. And the training objective is to generate an output that replaces the placeholders with the gold labels, because we have some placeholders and we also know the gold in the training data. There are other examples like life injure, somebody or some organization led to some victim injured by some way in somewhere. Or another example, conflict attacks, some attacker attacks some facility by some way in somewhere.